Okay, so far in this book, you've been making some great progress. You've learned how to create functions. You've learned how to use these repeatable, callable functions to perform some standard statistical data mining processes on data, no matter what data set you throw in there. But once you've got these functions created, it's kind of a pain if you have to copy them into every single IPy notebook that you want to use them in. So, for example, back here at the end of the bivariate statistics chapter, we came up with this awesome Biostats function that you can pass any data frame into, specify the label and what you want to round to, and no matter what type of data is in there, it'll automatically calculate the appropriate statistical test, whether a correlation, ANOVA, or chi-square on that data for you. However, if you copy this function into every workbook that you use, you could end up changing it here or there for different purposes, and you get these inconsistencies, and then you forget, okay, I've got a new version, where did I copy that to, where did I store that? We need to solve this problem. What we want is a single file, an external file that will store all of the great functions you create in this class or on your own, and then we want to import that file anywhere we want to use it so that it only actually lives or exists in one place, and every time you modify it, you're only modifying it in one place. So essentially, we want to make your functions importable just like these packages are here that have been created. So here's how we're going to do that. First thing first, we need to create a blank file. Now, if you're on a PC, you can use Notebook. Notebook is totally fine. I use a program called Visual Studio Code because I do other programming. If you want to use that, by the way, this is a Microsoft product. You can actually write Python in Visual Studio Code just fine. You don't even need to download Anaconda. Anaconda will run Visual Studio. It'll actually run within Anaconda if you switch to that earlier on in the class. But this is a great tool. It's very lightweight, but there's 100 of these out here, these IDEs that you can use to write code in. To make life simple, just so you can see that you don't need this, I'm actually going to go ahead and open up just Notepad. Now, if you're on a Mac, you've got, I think, Text Edit. Is that the kind of the simple editor that comes with a Mac? Text Edit, or you can also download Text Wrangler app, or just go ahead and get Visual Studio Code. It's cross-platform. It'll work on a Mac too. Basically, we just need an empty place to start storing files. So here's what we're going to do. I'm going to go ahead and grab each of the cool functions we've made. At the end of the univariate stats chapter, we have the full version right here. I'm going to grab that one. I'm just going to copy this right out of the book. Let's go and paste it right here. So I'm going to select all of it. Oh, just right to there, and hit Shift Tab to tab everything back. Oh, no, maybe Shift Tab doesn't work. Oh, there. No, it doesn't work in a Notepad. Okay, you know what? Forget it. I hate Notepad now. I'm going to go ahead and use Visual Studio Code. You can use Notepad. I just like the shortcuts. So let me show you what I mean. Here's Visual Studio Code. I'm going to go to File, New File, paste that in there once again, select all of this, and Shift Tab allows you to move everything back a tab one at a time. So kind of useful, then Tab to move forward. So here's my univariate stats function. I even have this nice little thing to do to collapse right here. I'm going to go ahead and save this file now. And I want to put it in, first of all, I'm going to save it as myfunctions.py. So you're used to .ipynotebooks.ipynb. This is just another type of file that lets you edit and store Python code. And in fact, it's a little bit easier to work with external functions when you use this ipynotebook file. So I'm going to save this. I'm going to go to my Google Drive, where we're keeping all of our collab notebooks. I've got this data folder. Right now, you're not seeing all of my IPy notebooks because it's storing in plain text. It's just not viewing them. I could change this to all files down here at the bottom. Oh, no, it's no extension. I don't have an all file type. Oh, look here, Jupyter notebook file. Now it shows me all my IPy notebooks. That's not what I want. I want to save this as .py, which if I look through my options, I should find, here we go, right here, Python. So you see this one because I made this same thing earlier. I'm going to save over the top of that. All right, so I'm going to hit save. Yes, I can replace that. Now it's all color-coded. It knows it's a Python notebook file, but it's going to automatically upload my functions into my Google Drive where I can use it in Google Colab. So now that I have Unistats, let's go ahead and copy in the rest of the functions we've made. So over here in the Biostats chapter, by the way, your chapter numbers might be ordered differently. This could be a standalone chapter for you. Just go to wherever you have the bivariate statistics in your book, or go to your IPy notebook where you've already written the function that you like and the way you like it and copy it from there. Anyway, I'm going to go through all the way to the end where we put everything all together. And we made a new version of the Pearson chi-square function. We need that for the biostats. So I don't want the function call just all the way through return. All right, and I'm going to come down here below Unistats, or well, it doesn't matter if it's below or above. Notice the difference between this format and an IPy notebook file is we don't have these code blocks that we write in. It's all just one document, and we run things. Oops, come on. We include all the functions in the same place, like it was as if it was one big code block. That's really the only difference, at least relevant difference for you. So I'm going to collapse this. I've got the Pearson chi-square. I've got my Unistats. Now I want to copy in my biostats. So I'm going to scroll down to the bottom of this chapter right here. Biostats, again, I don't need the function call. I'm just going to copy through return. Paste this right here. Let's format this nicely. Okay, I've got the 3 functions that we've made so far in this book that I think are useful that I want to use again throughout the rest of the book. So I'm going to go ahead and, oops, didn't mean to do that. Control N, enter line down there. There we go. Now, remember, the tabbing and spacing is important. So everything within this function has got to be tabbed in to the same level right here like it is. I don't have to collapse it. If you're using Notepad, you won't have this ability to collapse. It doesn't matter. Essentially, it's all still there. It's just kind of hidden to make it easier to see. So I'm going to save this file once again. Oh, I need to tab that in once more, don't I? Looks like I missed that. Tab that back one more time so that it lines up. There we go. Only one tab in. Same thing right here. Looks like it tabbed that stuff in a little too far. It would have still worked. I'm kind of being a little ridiculous. I don't need to do this, but there we go. All right. Oh, you know what? I also don't need this. I accidentally copied in all this function call from the univariate stats. This one, oh, look at that. I got a few tabbing problems. So double check, make sure everything gets tabbed properly. That's got to be inside the else. This all needs to be inside the if. Yeah, look at that. I somehow messed that up. So let's just double check. Inside the definition. Good. Now we got a for loop. This is all inside the loop. This is inside the if. That's better. Else. And then here it gets added to the output in the loop. Okay. There we go. All right. So print out, and I don't need this function call right there. Okay. So remember with the Unistats, we got rid of the return because we printed out these plots right here. So this will just print. This print command will work anywhere within the functions being called. All right. So I think that's better. Let me double check my others, make sure I didn't mess anything up. Oh yeah, I sure did. Look, this if is inside the for. No, it's not. Never mind. This is the right place. This is just checking to make sure we have less than 5, or checking to see if we have any cells that are less than 5. Then if flag. There we go. That looks right. All right. Now I'm going to save it. Now let's go to a new IPy notebook and call this thing. So collab research. Let's create a new, that's the chapter. Let's make a new one. And I'm going to call this the test my functions page. So let's go ahead and pull in a data set like we always do. Come on, connect runtime, mount Google Drive, run. Don't need that one. There we go. Let's go grab our authorization code. All right, I'm going to pause the screen so I don't show my code to everybody here, but just go ahead and proceed and grab your authorization code like we always do. Okay, paste it in there, connect. All right, there we go. Let's go ahead and pull in our data set. Refresh, drive, lab data. All right, and copy that file path. Let's go ahead and import pandas as PD. Let's make a data frame and pd.read CSV. Paste the path to insurance. Perfect. Let's run that. Make sure it works. Good. Okay, got a data frame. Now I have data ready. Now I need to connect to or import this function right here that we just created, myfunctions.py. So notice it appears here because I have that Google Drive sync installed on my machine. What that means, let me show you here, is that when I saved from Visual Studio to my Google Drive folder, which I get this if I install that Google Drive backup and sync, I can go here and I see all my Google Drive folders right here directly on my own machine. So I saved it here to this folder, and Google Drive Backup and Sync automatically recognized this and uploaded it into my cloud storage right here. Notice that when I created something in the cloud, it also downloaded it, this test my functions, back here to my machine. Anyway, all right, we have that now. Let me show you the code next to pull in the functions. So first thing we want is to copy this right here. So go to this chapter in the book where I show how to import functions, and let's copy these first few lines. Back here and test my functions. We can put it up here. This order doesn't particularly matter. Let's tab this back. Okay, so I'm importing a package called sys. This is, sys then has some properties and some methods. So system refers to the system that I'm developing within. These are a series of commands related to my Python environment. So I can use that sys to then say, let's append a path to my environment that I can work from. So up here, I went to content drive, and I actually probably could change that and just go ahead and mount that one directly all the way to my Drive Collab notebooks to save myself a bit of time. But anyway, if not, this works too. So system.path.append and point it all the way here to Collab notebooks. Then from my functions import, and I just list the functions that I want to import. So I'm pulling in the Unistats function, the Biostats function. Then I'm going to read this in, and I can just call them. Let's call Unistats, and let's pass in the data frame that we just read. Oh, and I've got oh, this is good. I'm actually glad we went through this. So when we made the functions in class, we had, as we worked through the notebooks, we'd already imported several of the packages that we needed. And so we might not have imported every package that was required inside of each function because we already had them imported previously in the environment. So going through this process helps you see, oh, what is my function missing to be a standalone function? So what I'm going to do is come back here now to our, there we go, I'm going to collapse these, back to our my functions file inside of either Notepad or TextEdit or Visual Studio Code. And I can see, oh yeah, sure enough, look, I don't have the matplotlib library being imported, but I'm trying to use the plot right there. So what I've got to do is say, add to my function, import matplotlib as PLT, and I think if I remember right, I think I need .plot. Let's pull it up and check. So you can always just go back to your book and say, all right, let's go back to Univariate Stats and see what we were doing at the time when we learned how to create histograms. All right, histograms are right about here. Scroll down a little bit more. There we go. From matplotlib, import pyplot as plot. That's what we're missing right there. So I'm going to copy that line head back here, and I'll just go ahead and paste that in. All right, so now inside of Unistats, we have what we need called in order to run this. So if I just save those, the squiggly lines will go away. Now here's a problem. This file has already been stored in cache in the working memory of this page. So when I hit save, it is going to automatically re-upload the correct version. And in fact, I can look down in my system tray. Let me show you what I'm talking about here. Right. I don't know if you can see this. This guy right here. This is my backup and sync from Google. It says updated just now, and I can see right here, my functions.py is synced just now. It's already been synced. So now that file's been pushed up there. However, it still takes, I've learned, kind of a minute or so for it to update before the new version will be read this way. Sometimes what I do is I come right here and I go to runtime and say restart this runtime. Yes. And it will sort of clear out right here. This is my cloud hosted runtime, my processor and memory that's being used to run all this code. It resets that, will clear out of cache. Sometimes I have to still wait a few minutes before I do that for it to actually like refresh over here in the drive folder. I bet we're good by now because I've been talking long enough. So let's run this. There we go, sure enough. Okay, that's fixed. And I didn't have to copy my function over. All I had to do was append my path here, and I'm all good. Let's run Biostats now. Biostats. So notice that you can not use the print command and it'll still print out the results from these things. I've also noticed that if I don't use the print command and I have two function calls, it'll only show the second of the two function calls. Anyway, you'll see what I mean here. df, let's use charges as our label, and let's have it round to 3 decimal places. Oh, I forgot, never mind. We have the print command inside of here. So it's going to print these out no matter what. That's fine. All right, so here's our biostats function. So I get all my Unistats details. I can look through here and I can see where I might have problems with some of my variables. I look down here and see, okay, if I want to print charges, it looks like smoker. I'm using F, that means I'm using a one-way ANOVA to analyze the effect of smoker, which means smoker must be a categorical variable, right? I know that because of which test we told it to use depending on whether the dependent variable was numeric and categorical and label was numeric. So in this case, charges is numeric, so it's always going to use either a correlation or a one-way ANOVA because that's what you use for numeric labels. And then the feature, depending on whether the feature is categorical like smoker, region, and sex, or numeric like age, BMI, or children, it's going to use a different test that's appropriate for each. Now notice again, I know we talked about this before, but effect size. This effect, I can't compare this F statistic to this correlation coefficient. However, I can compare their p-values. Now, this is not a perfect analysis for comparison, but for this stage, the data understanding phase, this p-value it's good enough for now as a way to compare across different types of statistics which variables have the biggest effect on charges. So clearly it looks like smoking is the worst thing you can do to cost your insurance company money. Now, these three p-values are all zeros, so aren't they the same? Well, actually, what I did in the function I created, if you take a look, is I allowed the decimal places to be their complete and full length, which is something like 12 digits. And then I sorted the table based on the full 12 digits, then I round afterwards. So what this means is the p-value for smoker actually is smaller than for age, but they all round to 0. Let me show you how you can tell. I'm going to come up here and comment out Unistats, and let's adjust out our decimal places all the way to like 12. I'm not sure if it was actually 12 or not. We'll see here. Okay, so I just got this table now. Here we go. It looks like as far as it will go is to 6 decimal places. However, just know that any internal rounding that was already done happened after this was sorted. So in other words, this p-value really is smaller than age. You just can't tell because they're all so tiny that it doesn't show up in the first 6 digits. So this is a great way, our biostats function. It took us a long time to get here, and now we've got it in an external file. It's ready to use in the future on any data set you have. but we have now a great way to quickly summarize the effect of each variable and rank sort them in order of importance in terms of their effect on the dependent variable. So smoking is the worst, being older is the second worst, having high BMI is the third worst, then evidently having children, although it's not it's on a completely different scale of effect to these first three right here. I would say these are our big factors. The rest of these are very, very minor in comparison to those, although all three of these are below 0.05. So just out of curiosity, let's try some others here just to make sure our function's still working. Let's predict something categorical. So let's see if there's a difference between men and women by predicting sex. So here's what will happen now. By using sex as the label, it's going to tell us how much each of the other variables are related to that. Now notice, because sex is categorical, it uses a chi-squared for all of these. Now you might remember we are bucketizing for all of our numeric labels, although we didn't handle bucketizing for categorical. So for example, charges is numeric, p-value is pretty small. So basically, one of these is costing a lot more. One gender is costing more than the other. It doesn't tell us, this analysis doesn't tell us which one is which though, because effect, a chi-square is always positive. We don't know if it's the male or the female. It doesn't tell us which one's larger or smaller. So I would still have to go back and look at my unistats to see. So I could look at this and actually no, that just gives me my univariate stats. So a good way to extend this function that we've created is that whenever it runs a chi-square, maybe we could do some summary statistics on the difference. Actually, no, you know what? The perfect thing is going to be when we get into visualization in the next chapter. So we'll add some charts to this next that will let us see whether males or females were the ones that were more expensive. Then let's see, smokers differentiate. So we're not sure which one is which again, but my guess is men are smoking more than women. And those are only two that are significant. The rest of these, because the p-values are so high, this tells us that there's no difference in BMI, region, children, or age across the genders in our data set. So let's do another interpretation here. Let's look at, how about, let's do region. Whoops, Shift Enter. So now this will tell us if our regions represented, if there's anything different across the regions. Significantly different. All right, sure enough, age. So age is very different across region. BMI is very different across region. Charges is somewhat different. It's still significant, but not nearly on the scale these are. It looks like smoker, it's a little over 0.05. Call it marginally significant. Looks like smoking varies by region, but children and sex doesn't vary at all by region. Let's do one more here. Let's do, what are the differences in children? Okay, so children's numeric, which means we're back into our correlation coefficients and ANOVAs. So here we can see that, yeah, charges clearly, and this is an R, which means positive and negative matters. So because this is positive, that means that more children leads to more charges. And it's significant, p-value of 0.01. These other correlations, because they're positive, this says that the older you get, the more children people have. But interestingly enough, it's not quite significant. Similar down here, the older people get, the higher their BMI goes because this is positive. But these scores could have been negative. Anyway, but once again, not statistically significant. So I would conclude that there's not an effective BMI on the number of children, or not a relationship between BMI and children. All right, I think that's a good place to stop for our univariate stats and bivariate stats. Now we know how to store our functions in a separate file. We'll use this technique from here on out throughout the rest of the class and the book, and we'll move on with visualization in the next chapter.